There's the magic sound. Name. Oh, I have to do my joke. And Circe. She gets everything right. All vectors have both magnitude and direction. It's a little too loud. All right. Cannon is fired horizontally. In my mind, I would emphasize the word horizontally. I'd say to myself, I'm going to draw a little picture, I think. I'm going to dull. So, sorry about the interruption. I'm going to draw a little picture. So it's fired horizontally. A velocity of 80 meters per second. And a 25-meter high cliff. And I'm going to break this up into horizontal and vertical. And right away I'm going to say AX is 0, AY is negative 9.8, and I have the components as well. VX is 80. What's my initial vertical velocity if we're launched horizontally? 0. Which makes this a lot nicer. And I know that my vertical displacement is negative 25. Why negative 25? Because I'm ending up below from where I started from. And I'm pretty sure using this I can find t. In fact, this will be kind of nice. I'm going to cheat a little bit. I'm going to solve this all vertically. So I'm going to drag the horizontal down to this question, because that's where I'm going to be solving stuff horizontally. Wouldn't that go? Wouldn't that go? How long is the cannonball in the air? I think I'm going to use D equals Vy initial t plus a half AY, AY t squared. But since V initial is 0, that makes my equation D equals AT squared. And instead of times a half MLE, I'll just put it over 2 because that looks prettier. And it also makes it easier to get the t by itself. How would I get the t by itself? I think the 2 would move up. I think the a would move down. And square root. I think t is going to be the square root of 2d over a. It's going to be the square root of 2 times negative 25 divided by negative 9.8. Bring up my trusty calculator. Thankfully, the negatives cancel, which is good because I can't take a negative square root. But, hey, it's going to be positive in there. 2 times negative 25 divided by negative 9.8 square root. Do y'all get 2.26 seconds? People nodding? I would take 2.3, but, 2 or 3 sig figs. 2.26 seconds. 2 marks if you got that. Otherwise, I would probably give you... If you didn't get the correct answer, if I saw that, that would get you 1 mark. If somewhere I saw that you would recognize that, that would get you a half mark, and then a half mark for the answer. In other words, Connor, you never leave a question blank. Part marks like crazy. Especially as we get further on in the year, you'll get 1 mark on the written questions. For me, they're almost all out of 7 marks, and you'll find out on your first test. It's just how they work. They used to always be out of 7 marks. Now they're out of 5 because they don't want to pay markers to mark anymore. The government wants to do it all computer-wise, and they have to pay markers, so they're trying to reduce the written section. Having said that, when I marked the Physics 12 provincial exams, in their marking scheme, you would get 1 mark just for writing down the correct formula because they wanted to reward you for recognizing, oh, that's not force, or oh, that's not electric field, it's displacement and velocity, and you should be rewarded for that. B, how far does the cannon travel horizontally? Well, now I also know that the time is 2.26 seconds, so the horizontal range is Vxt. What happened to the half AT squared? A is 0. So it's going to be 80 times 2.26 times 80. You got 181? 181 meters. Now, if you use 2.26, you might have got 180, I don't know, but 1.8 times 10 to the 2 meters. Next page. Oh, now we're being launched at an angle. Dulp. Draw a little picture. 28 meters per second. 58 degrees. And they want me to find Vx. And they want me to find Vy. Well, that's opposite, that's adjacent, that's hypotenuse. As it turns out, Vy is going to end up, Vy is going to end up being sine times the velocity, so sine of 58. And Vx is going to be 28 cosine of 58. And 28 sine 58 equals 23.745, 23.75. Now I'm going to write up here 23.75, but in my answer, I'll go to 2 or 3 sig figs, and to 2 or 3 sig figs, it's actually 23.7. Wouldn't that become an 8? Actually, not on the original number, it would be a 7. Just barely, but it would be a 7. What if I put an 8 there? I won't freak out, but learn to round off properly. And cosine, Vx is going to be 14.84. 14.84. I'll write that over here as 14.8. That gets you a half mark. That gets you a half mark. If you forgot your units, take a half mark off. Please, in final answers, we must have units. Same with here, by the way. If you miss the units, half mark off. If you miss the units, half mark off. What is the maximum height that the projectile reaches? Okay, they said maximum height. I'm pretty sure that means we're handling this vertically. I'm pretty sure that means that AY is negative 9.8. I'm pretty sure that means that VY initial is 23.75. What else do I know? Because that's only 2 things. I can't solve with 2 things. Maximum height. Oh, I know one more thing. What? I hope I know one more thing. Ah, VF is 0 at the very, very top. Not horizontally, still moving, but vertically. VY final is 0, and they want me to find the final height. Oh, I think I'm going to use this one. D equals VF squared minus VI squared all over 2A. I think. Right, the squared one, yes? People nodding vaguely. You could have found T and then found D, but I can get there in one fell swoop. It's going to be 0 minus 23.75 squared all over 2 times negative 9.8. And brackets, 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 0 minus 23.75 squared divided by bracket 2 times negative 9.8. And let's pretend, is my final height 28.8? People nodding? Meters. If you got the correct answer, 2 out of 2. Otherwise, I probably would give you 1 mark if I saw that, and then a half mark for plugging in the right numbers. Did anybody find T first? Okay. Got the right answer still? I was faster. Of course, now you have a shortcut for part C. Assuming you got part B right, and you have T sitting there, what's the answer to C? Take your T and do what? Double it. However, I'm going to find this myself. How long is the projectile in the air? So I know that AY is negative 9.8. I know that VY initial is 23.75. I know one more thing. If I'm starting on the ground and ending on the ground, I know the final vertical velocity. It's negative 23.75, and I can find T. T is going to be VF minus VI all over A. It's going to be negative 23.75 minus 23.75, close bracket, divided by negative 9.8. Did you get 4.85? 4.84? 4.8, something close to a 4 or a 5. 4.85 is what I'm going to say. Units, seconds. Number 3. Two forces act upon a point Q. Force F1 is 5 newtons due east. Oh, they gave me a direction. I'm going to draw my compass rose because the number of times I've got east and west mixed up would amaze you. They want us to find the resultant, so we're going to add 5 newtons due east to 12 newtons due west. Sorry, due south. West, whoop. Due south. And 5 to 12, I tried to draw 12 roughly twice as long as the 5. I want to be at least kind of to scale because it sure makes it easier for me to see if my answer looks right. The vector diagram. Hey, how do I add two vectors together, Joel? Draw them. Ah, good regurgitation of knowledge. 5, 12. This is my resultant, F, or R, or whatever you want to call it. I think when you do the Pythagoras, it works out evenly, does it not? I think you get 13 newtons. That gets you 1 mark. At, yeah, because the force has magnitude and direction, and I won't always remind you of that in the question. If I ask you to find a vector, you better be finding me magnitude and direction. How do I know I'm asking you to find a vector? You put the little stupid arrow up there. Oh, yeah. It's going to be this angle right here, theta. And I think theta is going to be the inverse tangent of, try that a little neater, Mr. Dueck, the inverse tangent of opposite over adjacent. I think theta is going to be the inverse tangent of 12 divided by 5. Boys and girls, is it 67 degrees or 67.4 degrees? I'm going to go 67 degrees. What of what? What of what? South of east. So here's how I mark these for 2 marks. 1 mark for the magnitude, half mark for the angle, half mark for the what of what. Now, you could also have given me the following answer, or 13 newtons at 90 minus 67 is 23 degrees east of south. Probably what that means is you drew the 12 first, and then you drew the east. But that's also the same answer. Again, 1 mark, half mark, half mark. Any questions? Am I right? Okay. I thought 4 was probably the toughest question on here. A plane travels at 220 meters per second due east. There is a crosswind blowing at 80 meters per second, 30 degrees north of east. What's the plane's ground speed? So here's what we said. Our thinking was velocity of the plane's engines plus velocity of the wind. That's what gave you the velocity with respect to the ground, what the radar tower would see. In other words, I'm going to add these together tip to tail, and because I've scrolled down, I'm going to add another compass rose here. Looks like it's going to be this. 220 due east plus north of east. There's east. There's 30 degrees north of east, and the crosswind is 80. How do I add 2 vectors together? Draw them. So my vector triangle is going to look like this. 220 plus 80. My resultant is going to be that right there. That's my resultant. how big is this angle right here? 30? Real question is then, how big is that angle right there? They add to 180. So now I have an angle inside my triangle. I know that this angle here is 150 degrees. SOHCAHTOA? No, no. Cosine law. You know how I know it's cosine law? Because there isn't a pair. I don't know both of those. I don't know both of those. I don't know both of those. I don't even hear it anymore. Cosine law. I really should find out who's teaching above me, shouldn't I? I don't know. V squared equals 80 squared plus 220 squared minus 2 times 80 times 220 cosine of 150. See, I'm the math teacher that does disco math, so I really can't complain to other teachers about noise. The velocity is going to be 80 squared plus 220 squared minus 2 times 80 times 220 times the cosine of 150 square root. As a magnitude, I get 241 meters per second. At. Now, my angle is going to be this here. Yo, am I wrong? Did I type it in wrong? Ah, sorry. The 0 didn't kick in. See it right there? Second function, insert, put a 0 there. I hit the 0, honest. That's going to make a huge difference. How about 292? How about 292? Jeanette, you get a candy. Right? 80, 220. Cosine law. At. Now, to find the angle, can't use sine, cos, or tan. I'm going to have to use sine law because now I have a pair. As it turns out, the sine of 150 divided by the side across from it, which is 292, I just figured out, that equals the sine of the mystery angle divided by the side across from it, which is 80. If I cross multiply, I'll get sine theta equals 80 sine 150 divided by 292. 80 sine 150 divided by my last answer. I get the sine of the angle is 0.1369. How can I figure out what the actual angle is? Brett. Inverse sine, shift sine, second function. Yeah, that button there. 7.9. If you said 8 degrees, I probably wouldn't freak out. I'm going to go 7.9 degrees. And I think it's north of east. I guess I have a spot for the answer, don't I? Why don't I do this and move the answer right to where it says answer. And why don't I do this? Oh, try that again. Draw carefully, Mr. Dueck. And let's move my work up to there a little bit. There. For 2 marks, 1 mark for the magnitude, half mark for the angle, half mark for the what of what. Oh, you could also get, what's 90 minus 7.9? 82.1 degrees east of north. If you drew your triangle with the 80 first and then the 220. Why you would, I don't know. Okay. Turn the page. A projectile is launched, as seen in the diagram below. If the height h is 36 meters, find the range. Well, I see an angle, so I'm going to find Vx, and I'm going to find Vy initial. Am I bad if I just jump straight to that it's 20 cos 30? And that it's 20 sine 30? And this one ends up being 10 meters per second. And this one ends up being, no idea, 20 cos 30. 17.32. I'm going to break it up into horizontal and vertical. Horizontally, I know AX is 0. Vertically, I know AY is negative 9.8. I know VX is 17.32. By the way, if these numbers seem familiar, I use the same diagram for a different height on a different question in your notes. Because these... Am I wrong? No? Oh, okay. Sorry, I was a little worried there. 10. Oh, and I know dy is negative... What did I say the height was, Mr. Dueck? Dy is negative 36. So now I'm committed. I'm going to find t. How many of you use the quadratic formula to find t? How many of you find Vy final and then use that to find t? Okay, I'm going to do that one since that's what most people did. Looks like some of you did neither. Okay. Turns out Vy final squared is going to be Vy initial squared plus 2AD. Vy final is going to be 10 squared plus 2 times negative 9.8 times negative 36. 10 squared, not minus, times 2 times negative 9.8 times negative 36. And I get Vy final. That's totally wrong because I have a times there, Mr. Dueck, instead of a plus there, Mr. Dueck. Come on, calculator. Plus. Did you get Vy final is 23.38? No, it's not. What is it really? I'm being fussy here. Negative. We're going down. Absolutely, we're headed downhill. Vy final is negative 28.38. Now I can find t. T is going to be Vf minus Vi all over A. It's going to be negative 28.38 minus 10 all over negative 9.8. It's going to be bracket negative this number minus 10 all over negative 9.8. You get a time of 3.92 seconds, whether quadratic or this. 3.92 seconds. And now I take this and I walk over here. I say t is 3.92 seconds. That means the range is going to be Vxt plus a half at squared, but Andrew A is 0, so I don't care. Turns out the range is going to be a lovely, lovely, lovely 17.32 times 3.92. The range is going to be times 17.3.32. You get a range of 67.8. Keep nodding. 67.8 meters. Now, if you got that, you get 4 out of 4. Otherwise, I would mark one as follows. I would give you a half mark if I saw that, a half mark if I saw that. It gets you 1 out of 4. I would give you a half mark if I saw that you were clever enough to recognize horizontal acceleration is 0. A half mark if you were clever enough to recognize vertical acceleration is negative 9.8. That would get you 2 out of 4. You've already passed the question just by understanding how to approach it. I would give you 1 whole mark if you found t. Now, if you got t wrong, but you took this number and you multiplied it by 17.32 and got a different answer, but you did 17.32 times your value of t, I will give you 1 mark for that. So you can still get 3 out of 4. I don't want to penalize you for the getting the remaining stuff wrong by finding 1 step wrong. Yes? What if you got Vx and Vy initial backwards, but you got all the math right? I'll give you 3 out of 4, but I'll also think such bad thoughts about you. Yeah, I get X and Y mixed up all the time because they sound so much like... You know what? Actually, it's great that you did it here because you'll be careful now on the test. And that is something that happens every year as well. Kids get the X and Y mixed up, and that's also one of those that drives me crazy. Those are the ones throwing away marks. That drives me crazy. Not understanding, then I say I can be a better teacher and help you learn. But throwing away marks, that's when I want to bring out the Nerf baseball bat and just start swinging left, right, and center. Can you give yourself a score, please, then, out of grand total 21? So what's your homework? Officially, your homework is start working away on this puppy here. Okay? Please remember, a complete handwritten answer key is online, so if you get stuck, it really is a great way to learn. Look at what somebody else did, and often it will be, oh, I got the X and the Y mixed up. Or, oh, I forgot the square root. Or you may be like, I know how to do the last 3 steps, but I can't remember how to get this started. Or you may be able to get partway there and you're stuck in the middle. A great way to learn. Look and see what somebody else did, and almost all of you will have your aha moment, and it'll stick better. So this is due the day of the test. If you don't have this, I have a few extra copies. Or you can print up a copy from online because it's also online. I handed this out when we started the unit. I always hand the review out the day that I start each unit. Okay? On Tuesday, I'll start class by saying, hey, any questions from the review? And I'll do about 10 minutes or so of Q&A from here. But if you raise your hand and you say, Mr. Dueck, I couldn't get number 17, I will automatically ask you a question. I will say, did you look at my online answer key? Be honest. And if you say, no, I didn't, I will say to you, can you go look at my online answer key? Because if you figure it out yourself, you will have learned it better. In other words, if you come here on Tuesday with a question from the review, make sure you've done your due diligence and actually taken the 30 seconds to go to Pit Math and click, 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 click. Now, some of you are saying, I can't remember where it is, Mr. Dueck. So if you go to Pit Math, oh, I don't have any bookmarks on this browser. If you go to Pit Math, if it works, if Pit Math chooses to load, should Pit Math actually choose to load, should the internet actually work, of course it's going to go slow today, why not? Are you serious? Nothing on the page, come on. Okay, got to the YOLA site. Come on. I can't stand the suspense here. Okay. There's 2 ways to get the Physics 12 answer keys. One way is if you click on my SkyDrive. That's this link right here that says click here to access notes. And that, if you go to Block G, Kinematics, it's always one of the first things that I upload. So if you sort by date modified, you will see Ultimate Kinematics Review. There's a blank copy. And Ultimate Kinematics Review Answers. The quicker, easier way is if you click on Physics 12 links, I have all the reviews that I'm going to be giving you out this year down here as well, along with answer keys. Whichever way you want to navigate there. Now, last year, I also scanned I used to do this by hand, by cutting and pasting. And so I have also reviews that were made by cutting and pasting, and those are exams that were before they were electronicized, before they were put into PDF. They're exams from like the 80s and the early 90s. If you finish this review and you want more practice, email me and I can send you another review and an answer key. In fact, I think I have 1 or sometimes 2 more reviews for every single unit. I'm not going to photocopy them because that's overkill for some of you, and some of you won't do it. I might email it to you guys if I can see how, if it's small enough to fit on the Check My Mark email system. But if you want more practice, the point is I got more practice. Okay? Okay. Let's start the next unit. So, Unit 2, called Vector Dynamics, is the topic. Unit 1 was Vector Kinematics. Vector because we were going 2 dimensions now. Components, components, components. Same thing here, Vector Dynamics. Now, most of you don't know what the word kinematics and what the word dynamics is, so let me put it into Physics 11 terms. Unit 2 is everything you did with forces last year, but now we're going to add 2 dimensions. We're not going to always have to push in a straight line. We can push at an angle now, or have things, the ground doesn't have to be level. We can put something on a hill now. We're going to eventually get a lot of 2-dimensional stuff in here. Vector dynamics. Dynamics is what makes things move. Kinematics is things that move. So vector kinematics, studying things that move. Vector dynamics, studying what causes things to move. And what causes things to move? Forces. So, lesson 1, and those of you that had me for Physics 11 last year, this is fairly similar to what I gave you last year. This should be, in theory, review for all of you, but I'm going to teach it from scratch because you may have forgotten. A force, well, one definition of a force is that it's a push. Whoop, let's try that again. One definition of a force is that it's a push or a pull. That's not necessarily the best definition, but it's easy to wrap your brain around. Are you pushing? Are you pulling? You're applying a force. It is a vector, and it has a magnitude, and it's measured in units of newtons, named after a scientist whose last name was? Very good. Forces are based on interactions between two objects. Some important forces that we will study in this course include the following. So example 1 says, fill in the force name and symbol. Here's the description. What do we call the force that is the Earth pulling on all objects downwards towards the planet center? What do we call that? Gravity. The symbol that I use is a capital F and then a lowercase g as a subscript. Fg. Which force is the microscopic hills and valleys between an object and a surface that interlock and prevent or impede sliding? Friction. I tend to abbreviate friction FF, or sometimes I'll put an FFR, F friction or F friction. I'm not consistent. I don't know why. But I've gone through my answer keys and noticed it seems to change from whenever to whenever. What's the force that is the surface pushing up on an object? You're all experiencing it right now. I heard it. The normal force, and that's one that's a really tricky one to wrap our brain around. The normal force. Now, look up. I have seen some, don't write this down, I have seen some textbooks use that for normal force, but don't write that down. The problem is a capital N also looks like north, and it also looks like newtons, the units. So I almost always will go FN. We were marking provincial exams one year, and the question said this: find the normal force. And a student wrote, which I had to give him credit. At least he knew the symbol for the normal force, but we couldn't give him any marks. And it was kind of funny, but yeah. You'd be amazed what you find on those provincial exams when kids are suddenly realizing their future is crumbling before their eyes, and they're just desperate for any kind of sympathy. Does anybody remember, what did we call the force from a stretched string? Jeanette, tension. I tend to symbolize tension with a capital letter T for tension. I really shouldn't, because capital T you're going to find means something else, but it doesn't mean anything in this unit, so it's a little easier to read. Then we have a contact force from an external agent, usually a person, an outside force. We call this an applied force. The question would say, a force is applied to an object, and what was causing the force? Invisible angels pushing on it actually is usually what I say, so that way we don't have to draw a person or something like that. We just kind of imagine there's some kind of something there pushing on it. And usually that one is F applied. The force of resistance from the air opposite to the direction of motion. Now, technically, this is called drag, air drag. But because we're going to keep the math really, really simple this year, because we're not going to get into drag coefficients and the vector surface area, the calculus-based surface area and shape of an object, I'm actually just going to say, you know what, it's air friction, and I'm going to label it often as friction, air friction. If you want to do it more accurately, take fluid dynamics, which I think is second or third year physics, which I've never taken. Wish I had. And the last one, it's not a force per se in that it never shows up on a free body diagram, but it's what we call the vector sum or the resultant of all of the forces acting on the object. We called it the blank force. I don't remember what word we used. I heard it. The net force. F net. And this is going to become really, really important this year. All forces can be described by three laws. They're Newton's laws. And I got to pause for a second. Put your pencil down. I got to give my props to Sir Isaac Newton. Now, first of all, in terms of his personality, he was a jerk. He tried to ruin other people's careers. He was jealous. He tried to hoard knowledge. He didn't believe in sharing knowledge. He liked discovery for the sake of discovery, but he didn't think that it should be shared with anybody. I got to get that out of the way, because often you'll see quotes attributed to Newton. The famous one, I think it's on his tombstone, says, "If I have seen further than others, it is because I have stood on the shoulders of giants." It's a very humble, kind of modest discoveries. There's no way he would have said that. No way. He was an arrogant SOB. He really was. But we got to give him credit. When he was about 19 years old, I think he was when he was 19, a couple of years older than you folks, he was at university and the plague came to London. And back then when the plague came to London, if you were in the gentry, if you were in the middle class, if you could afford it, you cleared out. So he went and lived in the country on a farm for about 2 years. And during that 2-year period, you could make the argument that no one in history has ever accomplished as much in 2 years up here. It's remarkable what he did in those 2 years. What did he do in those 2 years? Well, first of all, he invented the calculus. When we make it sound impressive, we put a "the" in front of calculus. So you say he invented calculus, but the calculus. He invented that. He derived an entire formulation of gravity. He realized that white light is actually made up of all of the colors. You've all seen a picture of a prism that's breaking the white light up into a rainbow. He came up with that in those 2 years. 19, not much older than you folks. And one of the many other things that he did was he thought a lot about motion and forces, and he was able to come up with 3 rules that explain everything. Not 10 rules, not even 8 rules, 3 rules. Beautiful. And in so doing, he was challenging 2,500 years of established physics. He was flying in the face of all of his profs. He was flying in the face of what everyone was teaching. He was saying, no, I'm right, you're wrong. What's his first law? Newton's first law says this. It's often phrased from the Latin, objects at rest tend to remain at rest. Objects in motion tend to remain at motion. The textbook that I stole this from said, every object in a state of uniform motion tends to remain in that state of motion unless an external force is applied to it. Here's Mr. Dueck's version. It says this. The only way that you can accelerate an object, and remember, accelerating is changing its velocity. The only way that you can accelerate an object, change its velocity, either change the magnitude of the velocity or the direction of the velocity, or both. The only way you can do that is to have an unbalanced outside force. And it also works backwards. If you're not accelerating or changing your velocity, you know what your net force is? 0. If you are accelerating, changing your velocity, you know what your net force is? Not 0. Okay? Doesn't mean that you're standing still. In outer space, you can glide forever because there's no forces acting on you. You'll continue going in a nice straight line at a constant speed. This is often called the law of Inertia. We have our Calvin and Hobbes comic here. Explain Newton's first law of motion in your own words. He looks confused and he has his brain wave. Yaka, Foob, Mog, Grub, Pubawump, Zinc, Watum, Gazork, Chumble, Spuzz. He has just explained Newton's first law of motion in his own words. That will not work on a test. Nice try. Turn the page. So there's a wonderful trick where a magician pulls a tablecloth out. Anyone can do it. And I think I have a video of it being done here, if I'm not mistaken. I should. Video clips. Give me a second. Let me find it. It's going to be under T for tablecloth, maybe. You know what? Let's go to not icons. I want details. There we go. Here you go. Right? The trick is to make sure you pull downwards so that the tablecloth is pulled straight sideways. If you lift up, you'll be adding an extra force up, and then Connor will get wet, which would be funny but not good physics. I mentioned earlier that in outer space you can continue going forever and ever, because in outer space there's no friction. What stops us here on Earth is friction. Of course, if there's no friction, we really don't know how to deal with that very well. So this road here happens to be very, very icy. And it's just enough, because ice does have some friction, a small amount, but still some friction, but it's just tilted enough so that the slant of the hill from gravity almost exactly balances out the friction of the ice. Basically, this is a frictionless surface when you add up the net forces, and people don't know how to drive on that. See, he's thinking, I'll give it more gas, I'll apply more force. What's the problem with that? My physics student, maybe Mr. Kamosi's, what force pushes a car forwards? Not the tires, not the gas. What force pushes a car forwards? Friction does. That's why you can't drive on ice. Most people don't realize that. They think, oh, if the tires move faster, it'll move forward. No. No. It's a Newton's third law reactive force. It won't work. Sitting on his deck with the video camera, just having a blast. And King 5, this was in Portland, I think. Now this person here, now how much mass does a car have? A fair amount. How much mass does a person have? A small amount. You're laughing, but this happens. People are stupid. They panic and they think, oh, I'll push on the ground. You're safe in your car. Stay in your car. You young drivers who are all of you dumb, stay in your car. Bad physics. So there's your Newton's first law, what life would be like without friction. And you got to give Isaac Newton credit, because 300 years ago, when people hadn't been much higher than a mile in a hot air balloon, he envisioned and imagined outer space and came up with Newton's first law. Got to give him credit for that. He was able to visualize, what if you were away from the Earth and planets and things? Up until then, everybody had believed that. Let me pause the video here for a second, so a little demo. Another one here. So this is a science program looking at an anti-terrorist device. Our world changed in 9/11 and 2001, and so security now is foremost on the minds of almost any major company, corporation, or certainly nation. And one of the things that they do is they put up big barriers that you can't through, but the problem is that you can't drive through. But the problem is, as soon as you put that barrier there, you're stuck with it there. Try going through the border right now. It's an adventure. You go through a little maze right now. They got barriers everywhere. So this company is saying, we can make barriers that will drop into the ground, so they're out of the way when you don't want them, but that will also raise up. Problem is, if it drops to the ground and raises up, how strong can it really be? Will it really stop an incoming car bomb?
Substitute for the potential explosive payload in the back, we're using a slightly more inert substance, bags of sand.
So here's a semi-truck filled with bags of sand instead of bombs. And there is their little hole that goes into the ground and pops out of the ground. Did you see Newton's first law? Did you see some objects continue going on their own inertia? Watch it when they show it again in slow motion. You'll see the truck stops, but because the sandbags aren't attached to the truck, they keep going. Newton's first law.
The truck is stopped dead. Though the cab and a shower of debris carries on forward, there's no way it could be going anywhere after this.
So the first part of this company's,
wreckage, but how's it taken the impact?
it stopped the truck. Question is,
it looks totally intact.
does it still work?
Even more amazingly, it still works.
So after that impact, the pole's mechanism
is a complete
still works
success.
just fine. Some good engineering there. Newton's first law. Newton's second law. Newton's second law describes the mathematical relationship that allows us to calculate the force on an object. F equals ma. That's Newton's second. Actually, Newton was much more interested in acceleration than force. He actually did A equals F over m but we write it F equals ma. We'll spend the unit applying this, so we'll explore this more later. Brings us to Newton's third law, the one that's the toughest to wrap your brain around. Newton's third law is often called the law of action-reaction. It's usually stated something like, for every action there is an equal and opposite reaction. Huh? This is Mr. Dueck's explanation of Newton's third law. Brett, forces come in pairs. Forces come in pairs, forces come in pairs, forces come in pairs. You cannot have an isolated force all by itself. You can't push on something without that something pushing back on you in exactly the same strength in the opposite direction. Or, as an equation, the force of object A on B is equal to the force of object B back on A, except Jeanette, negative in the opposite direction. You cannot have a single solitary force by itself. Forces come in pairs. If you push on Trevor, if you push on Joel, Joel's pushing back on you automatically. Could if you wanted to. Why would an athlete want low mass shoes? In terms of physics, why, if you were an athlete, would you want shoes that were lighter? So you want low mass because they have low mass. I want an actual physics reason. Pardon me? Okay. Let's assume a runner has maxed himself. Kayla, let's assume a runner has maxed himself out. He's lifted weights, he's practiced running, and so he's maxed his force out. If he's stuck with whatever force he can apply, if I can't make this bigger, how can I increase the acceleration? Do what with this number? Yeah, if that gets smaller, this is going to get bigger to give me the same force. Okay? Small m means big acceleration. That's why lighter shoes can help you run faster. Newton's third law, very tough to wrap your brain around.